Hi, and welcome to the sixth tutorial video on IoT and Embedded Cybersecurity. In the last video, I shared on how you can connect your IoT device, that's your Pico-W, to an existing IoT platform. And in that video, I showed you how you could connect to the IoT TeamSpeak platform. In today's video tutorial, I will focus on the third type of IoT setup, which is the custom app, building your custom IoT application. Now, for your IoT custom application, a lot of things are involved. This is particularly good if you want to develop your skills in different aspects of the IoT technology. First and foremost, you have your Raspberry Pi Pico-W or your W, which is connected to your sensors, your actuators, and this collects your data and is transmitted to your back end server, which consists of your database. So you will learn how to set up your database that manages, number one, your IoT devices, and also manages the data that comes from your IoT devices. You also need to know how to set up your um, application server, all right, that allows you to visualize your data either from your desktop, your mobile applications, your web applications, as the case may be. All right. So for us to be able to do that, we need to understand which of the IoT protocols that we are likely to apply. So in this video tutorial, I'm going to show you how to set up your MQTT. All right. Now, this is how to build a full IoT pipeline. All right. So first, we have our sensors connected to our Pico-W, and then from our Pico-W, we connect to our Wi-Fi and set up our IoT protocol for communication. That is for transmitting of our data to the cloud server. And in this case, we'll be using the MQTT. All right. So which focuses on publish, subscribes, and a broker setup. All right. So I'm going to show you how to use that publish and subscribe model. And on our cloud server, of course, we need our MQTT broker that receives our data from our Pico-W, and of course the database that helps us to save our data, and of course our backend that manages everything that happens between our Pico-W and our cloud server. Then of course we need a dashboard, all right? So an application server that provides us a dashboard. So we're going to learn how to build these in this series of IoT videos. Okay, so now let's look at how the MQTT architecture works. We have the message queuing telemetry transport, MQTT. Okay, it's a lightweight protocol that was designed for IoT devices. Why? Because some of the data we're transmitting from or will be transmitting from our IoT device are very small packages, small data sizes. Okay, so we need a very light protocol, and that's why the MQTT was developed. Okay, so the basic principle is this: you have your device. It could be your wearable smart wristwatch or your Raspberry Pi Pico-W connected to some of your sensors and all of that. So for it to transmit data, it's going to act as a publisher. So in this case, once it transmits, it is a publisher. All right. And once you publish, there are two things involved. One, the topic. Your message that you are publishing must have a topic, and of course your sensor data. Now, this is your MQTT broker. So your MQTT broker receives your messages and helps to forward it to any devices that subscribes to that particular topic. Okay. All right. So your device could be maybe your web application or your mobile application or any other device that listens to information or commands from your Pico-W or from any other device. So a subscriber must subscribe to a particular to the same topic that has been published by the publisher. Now we have different types of MQTT brokers that are out there. So just imagine a broker as a server if you're used to how the server works, okay? So it's more like a server, all right? So we have examples like the HiveMQ broker, we have the Mosquito, we have the EMX. So I will show you how we can use the HiveMQ broker in this video. Okay, so before we go into the setting up of our MQTT, I'd like to explain the different levels of quality of service that can be configured for our MQTT. So we have the QS0, QS1, and QS2, all right? So for the QS1, it transmits at most once, okay? So this is particularly good when you have data that if there's any loss, it does not affect the whole system. So example could be when you're transmitting your temperature data, humidity data, or sensor data every 5 seconds or every 3 seconds. So if there's any missing data, it does not affect the whole system. Okay. So for the QS1, so this basically means send at least once. Okay. So message is guaranteed to arrive at least once. Okay. The message is guaranteed to arrive at least once. Okay. So the broker sends back an acknowledgement, and if no acknowledgement is received, the sender retransmits. So the challenge with this is that sometimes there could be duplicate data, okay, or messages sent. Okay, so this is very important when you have things like alerts or notifications when duplicates are acceptable but loss is not. Now the last one is the QS2. Okay, so which means transmit exactly once, which is the most guaranteed form of transmission. However, um, however, it is the slowest. Okay, it is the slowest. Okay, why? Because the publisher publishes, the broker has to also communicate with the publisher. Then the publisher will reply. Then the broker will publish. So there's forth and back communication until the message is delivered. So this is probably the slowest form of transmission, and definitely the overhead in this case is quite high. So it's up to you, depends on the application. You can decide to make it QoS2 or QoS1 or QoS0. However, if you are looking at power consumption fastest, then QoS0 would be, and when data loss is not a problem, then I would suggest you use QoS for your IoT devices. Now we'll look at how to set up our Pico-W. So the first step is for us to install this library on Pico-W, that is MICROPYTHON_UMQT_simple. And to do that, you open your Tony ID, go to Tools, click on Manage Packages, and type in this MICROPYTHON_UMQT_simple. Then click on the search on Pi. Okay, so once you search, this will come up. Okay, and before this comes up, it might ask you, do you want to open this file somewhere? Just click on that link, then this comes up. Once this comes up, just click on install. So this will automatically install on your Tony IDE, on your Raspberry Pi Pico microcontroller through your Tony IDE. Now the next step is for you to connect to the HiveMQ broker. So in your codes on your Raspberry Pi Pico-W, you need to define your broker. So we're using the HiveMQ broker, then we're using the port 1883. Then of course we need to declare what our topic is. So for this example, I'm using this topic pico/olax/test. Okay, so later on I'll have to subscribe to this particular topic in order to receive the data from my Pico-W. Then of course the third step is to transmit our data to this particular broker. Then fourth step is for us to subscribe using a client. So in this case, I'm going to be using a public broker, okay, which is good for our test purpose. But in the future, you may want to use a private broker, or you may want to create some login for your broker in order to allow for authentication. Okay, so let's see how this is done on our Tony IDE. Now let's get on to the practical aspect of the IoT using the MQTT communication protocol. So first you need to make sure your Tony IDE is open, and you connect your Pico-W or Pico-W to your Tony IDE. All right, so then you go to your tools, manage packages. So we need to install the MQTT library. So you start by typing MicroPython underscore UMQTT underscore simple. Okay, so click on this search button. So make sure you are connected to the internet while doing this. So it says no results, try opening the package directly. So you click on this. Alright, so it gives us the latest version 1.34. So we can just click on install. Okay, so once it's successfully installed, you close this window. So you can see it's already on your, so it has created a live folder where it installs all the libraries. So if you go to MQTT, so you notice the simple.py is installed. All right, so this is the simple version of the UMQTT. And we need to also add the robust version. So with the simple version, it does not allow for a reconnection once you disconnect from the MQTT. So we need another version which is called the robust.py in addition to the simple.py, so that our firmware will become robust. So to do that, you need to come to this link. I will share the link in the description of this video. So make sure you are copying the robust.py. So click on copy. Okay, then go to your Tony IDE. Make sure you're on the directory of the UMQTT and where you have your simple.py. Open a new file, then paste the codes there. Alright, then save it. Select Raspberry Pi Pico-W and make sure it's robust.py. Okay, so click OK and you are done. So these two files are there. Alright, so we're going to be using these two files later on in the main code. Okay, so I've created a new file called the relay underscore DHT underscore MQTT underscore robust.py. So first and foremost, we need to import all the necessary library we need for this particular firmware. And next is to set up our configuration, which is one for the Wi-Fi. So for the Wi-Fi, we need to set up our SSID and our password to access point. Then later on, we need to define what kind of broker we're using. So we're using the HiveMQ broker in this case. So this is the broker name. If you're using Mosquito, you can replace with Mosquito or any of the other brokers. Then we need to set our port in which our broker will communicate with our system. Then we need to create our subscription topic. So in this case, my subscription topic, which I'll be connecting to later on. So the Pico2 will be subscribing to this particular topic, Pico underscore control. So I'll show you how I'm going to use that to control the relay later on. Then we're going to create another MQTT topic, which is the topic for our publisher. So our Pico2 will be sending data to the broker, so it needs to publish. So we're using this particular topic, Pico/data, as our topic name. Okay. So again, I explained that again. So this is for Pico2 to send data. So in this case, we are publishing. And if we are listening to commands from another device, so we need to subscribe. So that's why I define this as MQTT underscore subscription. So now for our publishing, that is sending of data from our temperature humidity data, we're doing that every 5 seconds. Okay. So everything is the same. Follow our previous videos. So this is to display. Okay. So go down. So everything is the same. Right. So this is to draw our Wi-Fi bus status. So we want to display our bar. So if your bar is greater than or equal to -50, your signal is quite strong. So you have 4 bars. But when your signal from your Wi-Fi is greater than or equal to -80, then of course your bar signal is weak, so it shows 1 bar. Okay, otherwise it shows 0 bar. Okay, so these are just for the Wi-Fi um, signal bar. Then this to display on our OLED. Alright, so I'll just go down. Now this for our Wi-Fi connection function. Now this MQTT callback is very important because this is what your Pico 2 uses to listen to any messages it gets from a subscribed topic. Okay, so in this case it's going to check if the message from the subscribed topic is on, then it's going to activate the relay. If it's off, then it's going to switch off the relay. So in this case our relay is active low, and so that's why it's a 0 value. Then of course if it's on, it will send a 0 value to our relay. Okay, so yeah, this is for you to initialize your client using all the client ID, MQTT broker, the port, and of course the keep alive for 60 seconds. Then the next thing that is very important is for you to initialize your callback. So client or set callback. So this, if you don't initialize this, then you will not be able to listen to any subscribed topic. So these are the functions. So just go through the codes. They are quite straightforward. So while this is the main loop, okay, so it tries to connects to MQTT, then of course it will check for message. So this is what allows your Pico 2 to listen to any message, so to keep checking for message based on the callbacks we have set up. Alright, so once we are done, let's run our code. Okay, so it says system starting, connecting MQTT connected. Alright, so it shows our status of our relay is off, temperature is 34, humidity is 14, and our signal level is minus 39 dBm. So you can see the Wi-Fi bar showing 4 bars, so which means our network is good. Okay, now that our system is up and running, so we're going to use an MQTT client from this link. So I'm going to share the link in the description of the video. So first we need to set up our topic which we want to use to publish to our Pico-W. Remember, in this case our two Pico-W are subscribed to this particular topic. Alright, so currently our relay is off, so I'm going to be sending a message to on the relay. Okay, so I click on publish. Hopefully, yeah, so our relay is on, as you can see, and it has changed the status of our relay, so it says relay on. Okay, so if I want to switch off again, so I'm going to put off. Okay, and I'm going to click publish. Okay, so it has switched off the relay. As you can see, the relay is off. So our Pico 2 is able to respond to a client, which is my system here, which has been set up connected to the HiveMQ broker, such that I can control the relay and I can switch off the relay. Alright, so if I want to listen to the messages from the Pico 2, that is the temperature, humidity, data, and status, so what I need to do is to click on this add to subscribe. Okay, then I need to put the subscribe topic. So again, let's go to our Tony IDE and get our topic from there. So this topic is Pico/data, so I'm going to copy, Ctrl C. Then I come to my, okay, so I'm going to paste it here. Okay, and I'm going to subscribe. Click on subscribe. Alright, so once I subscribe, so I should be able to see the messages from my Pico 2. So again, my Pico 2 has published this message to the broker, and because I subscribed to this topic, so I'm able to see that relay is off, the humidity is 14, the temperature is 34. So this is how your MQTT works. So in our next video, we're going to be using this MQTT protocol in our application, our dashboard application, in order for us to control our relay and to listen to our data from our Pico-W. So if you have enjoyed this video, if you have learned one or two things, please don't forget to like, subscribe, and share, and hope to see you in my next video. Thank you and bye.